A body starts from rest and moves with uniform acceleration of 6 meters per second square, full stop. What distance does it cover in the third second? Option A, 15 meters. Option B, 18 meters. Option C, 27 meters. Option D, 30 meters. JAMB 1992/4. Solution. They said a body starts from rest and moves with uniform acceleration of 6 meters per second square. Look up. Now, here is 6, and this side on here is acceleration, which is equal to meter per second square, while this side is t in brackets time. So here do you understand? Here first. Now, next acceleration. Next one, 6. They said acceleration of 6 meters per second square. That means the next one will be what? The next one will be what? The next one will be 12. Why the last one, the last acceleration here will be 18. How do you know that? That is 6, another 6, 12, another 6. 6 plus 6, 12, 12 plus 6, 18 meters per second square. Do you understand? Now, they said, what distance does it cover in the third seconds? This first second, this second second, this third seconds. Now, we are looking for this, so let's shape this portion to put our focus, on it, to direct our attention towards it. They're asking us now, what distance does it cover in 10 seconds? What distance does it cover in 10 seconds? Now look up. This shape now, is what? The shape of trapezium, am I correct? Yeah. This is what? A trapezium. Now, from here to here, from here to this place, from here to here is 1. Is that correct? Is 1. The height here is what? 1. Let me just say 1 meter or 1 centimeter. Let me say 1 meter. From here to here is the what? Length. This is height. This is height. And from here to here is what? Length. From this side to this side is called what? Is breadth or width. Did you understand? So our length here now is equal to, our length here now is equal to 12. And our height here, but let me draw it in a way you understand, let me not confuse you. Since we understood that this is trapezium, is that correct? This is trapezium. So, let me shift the diagram again so that I can put the figure correctly. Length here is equal to 12, height equal to 1, and breadth is equal to what? Breadth is equal to what? 18. Now look up here. Distance, they said, what is distance? Distance is equal to half bracket length plus breadth times height, which is the what? Area of a what? Trapezium. Area of a what? Trapezium. Eh? The shape here is what? Trapezium. Look at it here. Trapezium. So 1/2 bracket 12 plus 18 times 1. So this is 1/2, 12 plus 18, 30 times 1/1/1. So what do you have here? 30/2. And this is equal to, say x is equal to what? 15 meter. Final answer. Did you understand? So our answer here is equal to what? Our answer is option what? Option A. Did you understand? Now pay attention. Listen. In motion, remember velocity time graph is also motion. When we did velocity time graph, I told you that velocity time graph is a graph that, like anything graph in motion, gives accurate information on the motion of an object. Then we have distance time graph, we have displacement time graph, and we have velocity time graph. Now, anyone given to you, this one now is a displacement time graph. This graph here is a what? Displacement what? Time graph. Call it displacement time graph. This is displacement time graph. All these are under motion. So now they wanted you. They want you to leverage on the information you know about graph to find the distance covered. In this case now, equation 1 will not help, equation 2 will not help, equation 3 will not help, neither equation 4 will do what? Help. Just like the equation we saw before, there we will not apply any of the equation, rather we apply what? Calculus, differentiation, in order to get our what? Instantaneous what? Acceleration. The same applies to this question. For you to get your distance covered, we must apply this displacement time graph. Did you get? To get your what? The shape. And what is, if we are to speak on velocity time graph or anything graph, velocity time graph, for instance, there are shapes formed on the graph, and that shapes that are formed on the graph gives accurate information on the distance traveled or distance what covered. Okay, according to the velocity time graph, there are many shapes formed. You can find trapezium there, you can find sphere, you can find rectangle, etc. So the area of the shape is equal to the distance what traveled. Just as we apply the area of trapezium and we got our distance to be what? 15 meters. So that is the way it is done. That is the way you should follow it. So see you in my next class.